Hi, this is the ServoTester2 demo. It's USB powered, and we've got an SG90 servo, box standard, connected to the board. For this demo, I've got the normal wide switch in N, and it's in run. Come to all these switches in a minute. There are 3 LEDs for the servo current average consumption indication. Yellow means it's less than 500 milliamps. That's pretty much the default LED. The green LED means it's drawing more than 20 milliamps. I'm just stressing the servo here, but less than 500 milliamps. The red LED I'll demonstrate later. The pot controls how much the servo sweeps, and it basically has a default pulse width modulation of 1.5 milliseconds, and the knob controls 0 deviation from 1.5 milliseconds through to maximum, and I'll come to what maximum is in a minute. The logic inside the board has got 2 phases in oscillate mode, and they switch once a second. The pot value is added or subtracted from the default 1.5 milliseconds. If I apply too much torque to the motor, right, it shines red. It's more than 500 milliamps is flowing. The oscillator can be paused, and it's now in the phase it was when the pause was set, and the pot will now just move the servo in that quadrant, either adding or subtracting the pot value. If I want to get into the other phase, I'll put it in run and back to pause. It's now in the opposite direction, and I can use the pot to move it. This servo, by the way, has got a slight defect, and you're demonstrating it. I'm demonstrating it now at around this point here. It jitters. Has to be a specific pulse width. And I can't find it now. It's in there somewhere. Not sure if it's me jittering the pot. But the pot is actually slugged with the capacitor, so it shouldn't be. There we go. And okay, it's not drawing a lot of current, but it does jitter at certain settings. Okay, the normal wide switch NW, and if I put it back into run, I put it on wide, and it'll now do 180 degrees plus minus 90 degrees. Put it back into normal, and it's moving plus or minus 45 degrees, total 90 degrees. The normal goes from 1.0 milliseconds up to 2.0 milliseconds, and wide goes from 0.5 milliseconds up to 2.5 milliseconds. Other features are there is a jumper here which isolates the servo signal, so you can help determine if you've got a digital or analog servo in test. And the header here allows you to put an oscilloscope on the sense resistor so you can see what the servo current is doing. That test point is completely unfiltered, whereas the LEDs and the logic in the microprocessor, the sense current is filtered to 70 milliseconds to get rid of a lot of nasty spikes and make the LEDs look fairly clean. So the LEDs are showing average currents based on 70 milliseconds. There we go.